The directions say to determine whether the series converges or diverges. The primary focus in these examples is the root test. So let's take a look at problem 1. Suppose we have the summation from n equal 1 to infinity of n squared plus 1 over 2n squared plus 1 to the nth power. A sub n is n squared plus 1 over 2n squared plus 1 to the n. The nth root of the absolute value of a sub n, that's this guy right here, this is equal to the nth root of n squared plus 1 over 2n squared plus 1 to the nth. But you're going to be left with n squared plus 1 over 2n squared plus 1. Notice how the index of the radical and the exponent match. And so because they match, we are just left with what's inside the parentheses. And moreover, what's inside the parentheses is non-negative, which is why we don't need absolute value bars. Now, if we look at the limit as n goes to infinity of n squared plus 1 over 2n squared plus 1, we get a half, and that's less than 1. And so what that tells me is that the summation from n equal 1 to infinity of n squared plus 1 over 2n squared plus 1 to the nth power, that series converges by the root test. So let's take a look at number 2. Suppose we have the summation from n equal 1 to infinity of negative 2 to the n over n to the n. Now, a sub n is negative 2 to the n over n to the n. The absolute value of a sub n is equal to 2 to the n over n to the n. Because remember, the absolute value of negative 1 to the n, where n is a natural number, because that's what we're primarily focused on, this is equal to 1. Okay? So the nth root of the absolute value of a sub n is the nth root of 2 to the n over n to the n. Now, if this helps, you can think about it this way. This is equal to the nth root of 2 over n raised to the nth power. Notice how the index of the radical and the exponent match. And so we're left with 2 over n. If we look at the limit as n goes to infinity of 2 over n, this is equal to 0, which is less than 1. Okay? And so the summation from n equal 1 to infinity of negative 2 to the n over n to the n, this series converges by the root test. Number 3, suppose we have the summation from n equal 2. We don't always have to start at 1, right? And we're starting at 2 because the natural log of 1 is 0, and then it doesn't make any sense, right? Because we can't divide by 0. So circling back here, suppose we have the summation from n equal 2 to infinity of negative 1 to the n minus 1 over natural log of n to the n. A sub n is negative 1 to the n minus 1 over natural log of n to the n. Note, the absolute value of a sub n is 1 over the natural log of n to the nth power. The nth root of the absolute value of a sub n is the nth root of 1 over the natural log of n to the n. Notice how the index of the radical and the exponent match. And so we get 1 over natural log of n. The limit as n goes to infinity of 1 over the natural log of n is equal to 0, which is less than 1. So the summation from n equal 2 to infinity of negative 1 to the n minus 1 over natural log of n to the n converges by the root test. Suppose we have the summation from n equal 1 to infinity of negative 2n over n plus 1 to the 5n. Okay. Now, over here, a sub n is negative 2n over n plus 1 to the 5n. The absolute value of a sub n is 2n over n plus 1 to the 5n. So the nth root of the absolute value of a sub n is the nth root of 2n over n plus 1 to the 5n. And what you end up getting, and really think carefully about this, is you end up with 2n over n plus 1 to the 5th power. Because notice that 5n divided by n, right? So if I take the power and divide it by the index, I get a 5. And so this is what I end up getting. The limit as n goes to infinity of 2n over n plus 1 to the 5th is equal to 2 to the 5th, which is 32, which is greater than 1. And so what that tells me is that the series from n equal 1 to infinity of negative 2n over n plus 1 to the 5n, this series diverges by the root test. And that'll do it for this video. This is a video where we did 4 examples that related to the root test. So I wanted to show you the root test was applied. Okay, thank you very much.